It seems like every day we are reading about a business or industry that is making investments in green technologies. Going green isn't just for Fortune 500 companies, and the car wash industry has been a leader in this area, particularly in regards to water usage. Car wash operators are also finding new ways to reduce their environmental impact, while at the same time reducing costs. One example is electrical usage. So stay tuned as the Cleaning Edge takes an in-depth look at what's new and what's working in the area of power management.
Typically, car washes are cycling on high horsepower motors on and off all day long as demand comes into the facility, which can't be predicted. Some days it can, they're bumper to bumper, but most days it's erratic. And during that time frame, these horsepower motors are between, let's say, 2 and maybe the highest is a 25, or maybe even a 35 horsepower. That's what we call high horsepower. And the setup is normally using direct online starters, which allow uncontrolled voltage to go to the motor. Now, when you use that kind of a design situation, what are some of the positive and negative performance characteristics of direct online starting? Is there anybody that would like to handle that question?
I'll take that.
All right, Stan.
Well, first off, when you start starting motors across the line, some of the positives of that technology is that it's simple to select, it's simple to install, and from a replacement standpoint, if something goes wrong with it, it's very simple to replace. Okay. The drawbacks are, however, you're not taking advantage of some of the technology that's available that can save you money in either energy savings or peak demand charges. The other thing that the solid-state technology has for you is that it has predictive type measurements that can anticipate when a motor might be failing, for example, that can take you into a troubleshooting mode and take advantage of that technology before the motor were to fail.
Stan? This is an example of a 10 horsepower contactor and overload, which is used in a conventional car wash, starting motors across the line.
Okay. Now, Stan, you mentioned about direct online starters don't take advantage of energy savings. What might be a simple thing that you're talking about that a direct online starter can't control?
Well, when you start talking about energy savings, you're not using the full capability of using a variable frequency drive, which will throttle back basically the flow rates or the fan rate to compensate for that gap time when cars aren't lined up bumper to bumper. So instead of turning the motors on and off and then hitting those peak demand charges, you're basically customizing the application for what your load rate might be in the way of how often cars move in and out of the tunnel.
So I have a kind of an idea what a peak demand is, but I've heard that before, and I've been in the industry a long time. I'm not even sure what a peak demand is and why it causes me to pay more money for my electrical bill. Can you do a little bit of definition on that and explain it?
All right. Basically, peak demand is a measurement of energy use during a window of time that the power utilities dictate. So they will measure the amount of usage in a way of kilowatt hours or amps that you're drawing during that period of time. And you might only see that at the first time when the blowers start up during the beginning part of the day and not see that for the rest of the time that you're on operation. But however, if it's in that window of measurement and it hits that peak, the power utility has to provide that amount of power to you throughout the day. So that's what you're getting charged at, whether you realize it or not.
So if I go to layman's terms, we're talking about being charged all day long for a small peak period, which when I'm starting heavy horsepower motors like dryer fans or pump motors or something like that.
Absolutely. That period of time can be measured in oftentimes 30 or 15-minute intervals. But again, you're being charged as the owner of the car wash the entire time that you're in operation.
Thanks very much, Stan. I'm sorry, Tom. Go ahead. You have something to add?
Yeah, a specific example would be if you've got a 10 horsepower motor, it draws 14 amps full load current. But when you start that motor, it will draw anywhere between 6 and 14 times that 14 amps that you're associated with. And what you're doing with the drive or software, you're cutting off that spike. That's the peak demand, the difference between full line current and the spike you see when you start the motor.
what are some other technologies available from the world of automation that could be used in a car wash instead of using direct online starters?
Well, you could use, for example, a soft starter.
This is a soft starter?
This is a soft starter versus your conventional across-the-line starter. What it saves you is that it saves you the peak demand, although it is a less intelligent device. It costs a lot more money than a across-the-line starter, but it has some features and benefits in it that will save you money down the road.
Okay. Now, is there anything else besides this soft starter that can be used?
Well, when you go to a soft starter, let me just add one other comment. A soft starter is often referred to as a reduced voltage starter. And what that does is it allows you to start the motor with less than 100% power. Okay, that's where the soft starting comes from. That's where you can shave some of the peak demand charges. The other technology that's available is the variable frequency drive. And some of the advantages of using that is that it's an automatic control. It will automatically adjust to whatever flow or whatever rate of air movement that you need to operate the car wash. The other thing that you get is an inherent soft start. So built into the variable frequency drive is the ability to shave that peak demand that you saw in the cross-line type starting. And then lastly, as far as energy savings, when you start reducing the flow rates on the fans and the pumps, you automatically save energy because you're not at 100% potential.
Okay, Stan, earlier when we were talking about all of the devices and we were preparing for the interview, you gave an analogy of a light switch and whatnot in these devices. Would you mind going through that again?
Right. If you think about the cross-line starter as a manual light switch, that's exactly what it does. It's either off or it's on. The reduced voltage starter or the soft starter basically allows you to do some a dimmer switch type control, which gives you gradual increasing of power or reduction of power based on what your needs are. But again, you would use a soft starter just to shave the peak of that inrush that you would see from across the line. Now, when you go to a variable frequency drive, you have now an automatic dimmer switch that self-calibrates, self-adjusts based on the load demands.
The energy savings potential of an application is based on the operating profile of the application. So by reducing the speed, you're reducing the power which is consumed. Now, if you take an example of a blower in a car wash, you can think about how when you have a break in line, you would like to reduce the speed so that the fan is now not running at full speed right now, but at a lower speed, and you're saving that amount of power, and the power consumed is lower. Now, I have a demo here with a variable frequency drive. Now, if you look, the drive is right now running at 60 hertz, which is the rated full speed. Now, if I move on to this graph, which is basically a pump performance graph, but if I can relate that to a blower in a car wash, what we're looking at is if I'm running at a certain flow, my power consumed at 100% speed is about 100%. Now, if I reduce the speed of the variable frequency drive, I can see that the power consumed goes down. So reducing the speed from 100% to 80% reduces the power consumption by about 50%.
Okay, now in that case, the example you were giving, for instance, with the dryers, is there's a break in the line, and rather than turning a direct online starter, your option would be to run at full power until the car that's the second vehicle coming gets there, or you could turn it off entirely and restart the whole system and have a peak demand spike in doing so. In this case, what you're suggesting as an opportunity, if somebody deployed a variable frequency drive, is while you're waiting, you could reduce the speed of the motor, thereby reducing energy consumption very low, and when the vehicle approached, turn it back up and ramp it up back to full speed. That's correct. Real cool technology. I want to say thank you from the International Carwash Association and all of its members. Tom, appreciate it. Stan, thanks so much. And Sharon, thank you very much. We're signing off from the Rockwell Automation Fair in Chicago, Illinois.